Here we are again, same car, Mazda 6, and doing a continuation of the test I was trying to explain. I've got a few questions to explain it further, what you're going to see in there, and that's what we're doing. What I did was I removed the negative battery cable and connected a hose clamp with a piece of little short jumper wire right here. I did not reset the car. There's a way to do this. It involves jumper cables and a battery. So what you do is connect the battery to the positive over here, one, and just connect the negative to this engine lifting hook. That way, when you disconnect your main battery, the car then runs off the jumper battery that you've installed. You do not lose any memory, any modules. You can use this same technique when you're changing batteries on a Mercedes-Benz or any BMW or any other car that requires initialization again, like a radio code, power window initialization, or sometimes the transmission shifts funny because it actually loses its memory. So, and people then complain, hey, my car is acting funny. Anyway, so you can use that jumper, just put it on, and connect it to the car. So when you disconnect your negative, it doesn't lose memory. If you want to change the battery, you can actually connect a small jumper lead here, which is the same cable here. This goes to this. It's a simple wire. You can connect it here so it doesn't lose memory. Or if you have the battery in the back, you have jumper points in the front connected there. Well, it's the same concept. So now I'm going to tell you how this jumble is connected. Okay, so here is our hose clamp with a jumper wire here. Then we got an alligator clip jumper going to the black lead of the multimeter, which is connected to the 10 amp circuit here. This is a pretty cheap multimeter. You don't need a very fancy high-tech one for this because the range that is provided by the manufacturer is somewhere like 30 to 50 milliamps, so it doesn't matter. You don't need a super fine one unless you have a hybrid car, then that's a different thing. The other end of the multimeter, the red one, is connected here, which is then jumpered to the car's own negative battery terminal. I've also jumpered a black wire between the two, effectively canceling this out. The reason I did that is because the car needs to go to sleep once you lock it up. If you do not connect that jumper, leave this connected in there, this will automatically shut off. Once this shuts off, the car disconnects. Your test has failed. Because the whole system needs to be reinitialized, it'll take a long time. That is why this is here, because the car takes close to 30 minutes or up till 40 minutes to sleep. In this car, I know for sure it's about 14 minutes before the entire bus networks shuts up and just stops talking. Okay, continuing again. So the multimeter is now on. The car has rested. Systems are in their hibernating state. It's not actually locked. I don't need to simulate the whole thing because there's nothing wrong with the car. I'm just trying to show you how to test it and what you may see. So let's connect the short jumper, which actually will disconnect the short. Now, the entire car's negative system is now flowing through that. Please do not try to start the car. You will blow your DMM, and you may melt these tiny cables because they cannot pass much amps. So here you see we are at 0.02 of an amp, which is close to like 20 milliamps. This is not a very finely calibrated meter, but according to Mazda, your dark draw ampoule should be between 20 to 40 milliamps. We are seeing 20 milliamps right here. You may notice it's now at close to 2 amps. That is because I've opened the door to simulate a draw, a load draw. That's 1.9 amps. So now you can, well, again, I'm going to show you what I'm talking about when I tell that the car needs to rest and go to sleep. This is 2 amps. The reason is the dome lamps in this car, there are a total of 4 of them. Each one has a 5-watt bulb in it. That's a total of 20 watts at 12.6 volts. Anyways, so this is a 2 amp load. If this remains like that overnight, you will not be able to start the car in the morning because the battery will have run out. This is quite something. Or if you have a really good battery, 2 days tops. So now I'm going to close the door and you're going to see the amps go down. This car has a delayed shut-off for the dome lamps, so it's going to remain at 1.3 as the dome lamps go off in a bit. There we go. So it's still pretty high. That is because the BCM is actually awake. BCM meaning the body control module. We're just going to, you see it's now coming down. It's gone into its standby state now instead of awake. And if we just keep on waiting a bit more, it will eventually go back to the 20 milliamps to between 20 and 40 milliamps. Okay, I had a question about what I was probing when I was testing the fuses. So here is that answer. Every micro fuse or any type of blade fuse in an automotive car has 2 endpoints. One here, one here. You can see that. All fuses have them except these ones. These are to test these. To test these ones, you need to actually get some spares with blown off glasses, or you can break this off, which I don't like. So I replace them with my own test ones. Just make sure they're the right ampacity. For example, this one is 40 amps. So if I'm going to test this fuse, this circuit, I'm going to get some old ones, 40 amps, break off the glass and test it that way. That's the correct way to do it, rather than break someone's fuse. So we're just going to test the micro fuses here, the blade fuses. I'm going to show you what to test. So here's our multimeter again. It's on DC volts. We're going to test the draw. We're going to test the voltage drop in between here. So here I am with the fuses. I've connected both my probes to the tails of it. Went to 0 volts. Couldn't see it because I was focusing there. So I'm just going to lift it up and put it back. So it starts and goes to 0. I'm going to test this one. Here we go, touching it, fully in. Went to 0 volts. There's no load in this circuit at all. Because I was focusing there, I'm going to lift the probes again, contact them back. Lifted them, contacted it back. Went to 0. Here. Went to 0 again. So I'm just going to lift it, put it back. You see, it starts and goes to 0. This is a good, healthy, correct working circuit. There is nothing remaining on or stuck. This is exactly what we want to see. So resuming again, I connected the jumper up because I actually switched this off. I don't trust this multimeter because it's a lazy one. It tries to goes to sleep. It's like my cat. Anyway, so I'm gonna now disconnect the short jumper and see. So it's at 50 milliamps. The car is still in dormant state. It has not fully gone to sleep. So this is actually what I was talking about. In a CAN bus network car, or any car with any like body control module or any other, even fuel pump control module, this will happen. So this may throw you off. Do not try to do the test lamp in that or any other old school way. It doesn't work and you will fail. I hope this helps you. If it any way helped you, pay it forward. It's the COVID-19 is pretty tough. A lot of people need help. So just help someone today.